Lesson 1.6, Video 2. So let's do some examples of coming up with an equation of a line parallel to another line. So here we are given a point that our new line is going to go through and a line that we are parallel to. So this would be the line we're given. This would be the point we're going to go through, and we want to draw a line that is parallel to it. Okay, so parallel means that the slope is the same for both lines. So we're going to take this information and use point-slope form. So again, point-slope, we're going to end up with y equals mx plus b, but we're going to use point-slope to help us get there. So again, here is point-slope formula or equation. We have the slope we need right here. So we put that in. Now again, our lines are parallel, so we're going to use the same slope. If it was perpendicular, that would be a different story. So please pay attention to the fact that we're dealing with parallel lines. So same slope. Now, well, I guess we don't need these here. Let's plug in our points. Okay, so we know we're going to take y minus y1. Again, in our point given, the first number is x1, the second number is y1, excuse me. So y1 is negative 5. So we're going to subtract a negative 5. Then we're going to go x minus x1, which is a negative 3. So x minus a negative 3. We'll clean this up and we have y plus 5, because minus and negative is plus. 7/3, and then x, again, minus and minus is plus. And that's our equation in point-slope form. We want slope-intercept form, so we would solve for y. And as we did before, we would distribute the slope and get y plus 5 equals 7/3 x plus, remember it's 3 over 1. So numerator times numerator is 21. Denominator times denominator is 3. So 3 times 1. Alright, so that's a 21 on top there. Now, if we take this up here, we have y plus 5 equals 7/3 x plus 7. So now we can finish by subtracting 5. We end up with y equals 7/3 x plus 2. So again, we went from a point and a line that we are going to be parallel to. We took the slope from the line we're parallel to and used it, used our point we were given, and we came up with an equation in slope-intercept form. Quite a few steps, but it does take practice, but it is very manageable. The second example I'm going to do in class. So let's go to the last one here, where we have a point given, and again we're parallel to this. Now let's think about what that is. Y equals 3. We've talked about vertical and horizontal lines, and we know that an equation of the form y equals a constant is a horizontal line. So that is y equals 3. We want a line parallel to it. Now if it's parallel to that, it's going to have the same slope, look the same, so we know right away that it has to be y equals something. Well, here's our point. It has to go through negative 5, negative 3. So here's the point that we have to go through. They have to be parallel, so therefore this must be the line. It's horizontal again, so we know that all horizontal lines have the form y equals a constant. But what is that constant? Well, it intersects the y-axis at negative 3, and if you notice, it also happens to be the same value as the y value in our coordinate we went through. So a special case, but as important as the others. So this is lesson 1.6, video 2.